Hi, everyone. Uh, I'm Mahendra. I'm an enterprise architect in SunPower. Uh, so I actually look after the IT architecture and process excellence for supply chain and manufacturing applications in SunPower. SunPower, for people who don't know SunPower is an energy company. We design and produce solar panels. We have our own native design and research labs in California, and we have our factories in Asia, Europe, and Mexico, and all over the places. And the SunPower production actually has two important steps: fabrication and Matco, we call it internally. The fabrication is the step where we convert a silicons into a solar cells, and then Matco is a place where all these cells are assembled into a panel. This fabrication process is very important because that directly affects the quality of the panel. And our efficiency, SunPower's efficiency is the highest in the world. Each solar panel SunPower produces, on an average, produces 360 watts. Compared to our competitors, it's somewhere between 250 to 270 watts. So to maintain that efficiency, the fabrication is very important. Our fab factories have to really work smarter to maintain that efficiency. So the data lake we are preparing actually. We are still in the journey, and we have actually very good results. I have like two slides, the current state and the early state, which is going to actually help you compare where we are in this journey. And highly automated smart factory setup needed a scalable and secured and cost-effective data lake solution. That's what the goal when we started out. And our business goals are, what do we want to get out of this? We want to actually get more than 95% product traceability. So when I say product traceability, straight from solar cells to the customer's roof, we need to have an end-to-end traceability. That will actually also help in increasing our yield 20% from our current state. And that's our short-term goals. And then eventually we also want to get to the predictive and prescriptive models. But you cannot actually build a foundational architecture today and then transform again for your prescriptive and predictive use cases. So we need to put the architecture really a good foundation to scale up. This was our initial state. So if I focus on this block diagram, so there are three layers: collect data, prepare data, and consume data, if I simplify it. And this is a very watered down, simplified architecture diagram here. So the first, in the collect data, in production line, in the edge, all our machines are smarter. They have their not just sensors and cameras, they also have their native memory and computing. What does it mean? Whatever the sensors and images actually getting collected, they can actually immediately be converted into digital form. And all the open standards and everything gets simplified in the machine tool and the edge level itself. And you have your we have our manufacturing floor, we have our hosted PCs, device managers. So those control these devices and collect and aggregate this data. And then eventually we have a big ETL layer. We had a big ETL layer, which actually, based on the data source and type, put this data in different destinations. We have our virtual machines to store the images. Structured data goes into manufacturing execution system to perform, execute our transactions. And then we had one custom RDBMS platform where we used to put semi-structured or unstructured data. There we actually continue to prepare the data, and then eventually we upload all the data to public cloud. Apart from this manufacturing, devices and MES, we also have enterprise private cloud, which hosts ERP, PLM, QAS, CRM, and few other factory sites. So I've been focusing only on the fab. If you have another Matco factory, even that data also actually need to be merged with this data coming from fab. So all this actually, yeah, so all this data will find its way, used to find its way in public cloud. And then we also build operational reporting. It's redundant, actually, if you ask me. Why? Because both of them are going to give reports, analytics, But why did we build operational reporting? Because the time to take this data all the way to the cloud and merge this different disparate data sources took almost a day or two for every data set to reach the journey. So we cannot actually cater real-time or close to real-time operational reporting requirements with this architecture. So we ended up actually taking some shortcuts, collecting some data from MES and RDBMS and created an operational reporting. So this is more reactive. So what are the problems in this architecture? ETL. So the ETL model we had, it needed a host, and it was pulling the data from the data sources and pushing the data to the destinations. That means high latency. That's not a good integration pattern. And difficult to scale because it's heavy. Difficult to scale not just in terms of technology, even in terms of people. So if you actually hire an ETL developer, he's not going to do anything else apart from ETL. So if you want to peel off ETL, then you have to take some hard decisions. That's not going to be scalable. And hard to change. Even with the heavy infrastructure, what we were doing is we were only structuring and using only 30% of the data which the smart machines were producing. An RDBMS data warehouse. So that's definitely not scalable because it's already a dated architecture, difficult to scale. VM for images. So virtual machines. So when I say virtual machines, that means you have your storage and compute put together, and you have a virtual machine. So that's not cost effective to store machine logs and images. We have better object storage is actually available these days. And it's not going to be scalable, okay? And data consumption. After all this, heavy architecture, your visualization is, as I mentioned, this whole engine is going to produce only 30% of the data what you want to see. So that means you cannot scale this data visualization. So when I say data visualization, your tableaus, Click, or any dashboards you create, all of them are based on only the 30% of the data of what you produce today. So how about you actually upgrade your machines? Tomorrow it produces more data. How are you going to scale up? And if you want to do machine learning, predictive and prescriptive, this architecture won't help. So what we ended up doing. Current state. So we haven't actually changed completely. What we have done is we have the notable differences is we have taken off the ETL layer, we have taken off the RDBMS, and we have brought in object storage instead of VM and the data lake, and then all of this actually gave some results. So I want to bucket I would like to bucket the improvements in 3 categories: security, scalability, speed, and total cost of ownership. Because these are the important drivers, right? So security, data is encrypted at source, in transit, and destination. In my previous slide, I didn't touch on the security aspect. But security is very important because when you're in a manufacturing company, you have everything. Actually, we used to do all the MES were locally installed and on-premise. So people don't really pay a lot of attention to the security. But when we go to IoT and digital transformation journey, you bring in the cloud. So when you bring in the cloud, in cloud, you have a lot of features which actually expose your data to the outside world. So you have to be worried about security. So how you are transmitting the data all the way from your machines to the cloud, you have to be concerned, and you should encrypt the data at source, in transit, and destination. Okay, scalability and speed. How did we achieve the scalability and speed? Our biggest driver was we changed the culture in the way we are seeing this whole architecture. We separated the storage and compute. The 2 different levers actually allows us to actually handle situations like steady data growth and diversity of data sources and types. So if I have to simplify this statement, you have a big data mart or RDBMS or any data warehouse. So if it combined, the storage and compute is combined. Say today you have actually identified some formulas, machine learning algorithms, and your data set is say 1 petabyte, and you're running all your machine learning and everything. But your machine learning is not going to actually change for the next 5 years or 6 years, but your data growth is not going to be the same. Every day, every minute, actually, the data is growing. So your storage is growing, and your computing needs are actually, the computing complexity stays the same. So you don't want to actually keep these two levers together. So you have to separate them, which will allow you to actually, handle steady data growth and the diversity of data sources and types, which we cannot predict. We don't know what different machines are, what different data sources we will be plugging in tomorrow. And optimized file formats and data preparation at the edge. So another simple solution everyone goes for is, I'll dump the data in data lake, a centralized data lake, and from there I create the dashboard. That's the first step. Then I would do machine learning and stuff. But it's not as simple as we think. Okay, so you need to use file formats, and you need to leverage the edge computing. So when I say storage and computing, the compute is available today at each and every layer, at the edge, and in your own data centers, and as well as in the cloud. So it depends on actually which industry you are from, and what kind of latency, what kind of use cases you have. So you have to make use of all those compute layers. So what does it mean? Practically, IT works separately and manufacturing works separately. IT engineers may not even know how these smart machines work. And because these smart machines, even in our experience, normally the industrial engineers work with automation vendors and then design these machines actually, from ground up. It's not off-the-shelf products actually we procured and then put these machines in our production floor. So that means that knowledge stays only with that engineering and research. It's not carried forward to the IT. So we all have to work together and find out a way to leverage this computing power that will overall add a lot of speed, and it will help achieve close to real-time data replication. Data catalogs help to deliver faster query performance. So data catalogs. So one thing is, even though actually we have high goals, bigger goals, but we will not be using the data, all the data sensors producing or the machines are producing. We'll be somewhere between 10 to 15% of the data only we will be leveraging. Rest of the data, what do we do with that? We should have some strategies around it, and we should catalog this data, parse the data, catalog it, create data catalogs, and use it in the future. And total cost of ownership. Cheap object storage cost in public cloud, it's definitely a big advantage today, but without the data catalog, you will not get the best out of it. Slow and steadily, you will end your AWS bills and Azure bills will go up. And data governance and archival policies will keep your storage and cost constant. And what worked for us, in a nutshell, hybrid cloud model, cost-effective and flexibility to change. So we didn't go to one just big cloud architecture. So what are the lessons we learned? No monolithic package solution. Hybrid works better for smart factories because there are different vendors who give solutions at the edge, at the on-premise, at the cloud. So it's up to the organizations to pick the best and then create the correct combination. I think hybrid cloud will stay, and everything will not go to cloud as far as the manufacturing is concerned. And separate storage and compute. I've already talked about that. And edge computing and optimized file formats help reduce the latency. Don't leave the data unstructured for too long. There's a term actually you must have heard of, dark data. So you will not know, what you're going to do with all the data you're generating today. So you may want to actually parse it, structure it as much as you can. Maybe some of the data you may not be able to structure it, but structure. Don't leave the data unstructured for too long. And there are plenty of options available out in the market, which are cost-effective and flexible and scalable. Monitor and monitor and monitor. We are still learning. We haven't really reached our targets. We are still learning. Our targets are actually, we have our roadmap actually for next 5 years. We are still evolving. And every day we monitor how much data we are moving from one place to another, how many programs are running, what is our workloads, everything you have to monitor. Then only you can really understand the ROI out of this exercise. That's all I have. We can break into groups, and I can answer question in detail if you have any.